welcome back to SciByte, everybody, where we explore the mysteries of the infinite universe and all the tools and technology that science is using to get to the bottom of all those individual mysteries. Now today, as with every week, until you get sick of me and try to make an internet petition to oust me, my name is Jeremy and I am your host, but I'm not alone. Joining me on the Skype line like every week is Heather.
Hi guys, this week we're going to take a look at near-Earth objects, what they are, what danger they pose to us, and even some of the technology that we use to watch them and look out for them and see what they are.
Now, you've just called them near-Earth near-Earth objects. I'm sorry. I'm going to make that mistake multiple times in this episode, by the way, calling them near-Earth asteroids, because I've been raised as just calling them asteroids, which is kind of the point that I'm getting at here is near-Earth object actually a scientific terminology,
yes, it is
technical term?
Yes, because it encompasses comets, asteroids, meteoroids, any object that orbits the solar system. Now, near Earth means it brings it within a proximity of about 1.3 times the distance from the Earth to the Sun, which is a little over 15,000 times the diameter of the Earth, or a little over 500 times the distance from the center of the Earth to the Moon.
Well, yeah, if you think about it, 1 AU is, you just said, the distance from the Sun to Earth, which also encompasses the orbits of Venus and Mercury, and so so calling them near Earth objects might be a little bit of a misnomer. I mean, astronomically speaking, when you're comparing it to the size of something like the Milky Way, sure, that's really darn close. But not as far as like, I'm going to walk down to the neighbor's house. He lives nearby. Not the same thing.
No. Yeah, that's the trick with astronomy. They'll say soon or nearby, but astronomically speaking, things are astronomical in size.
Right.
They're much larger scales, and astronomers are just very used to saying, it's going to happen soon, and it means maybe in a million years.
Now, okay, so asteroids are just one type of near-Earth object. So comets, I had been raised to just always call these all asteroids. So comets, asteroids, meteors, meteorites, all of these are different things. Why don't we go through really quickly and kind of define them really quickly so that people have a little bit more of an understanding of what exactly folks are talking about when they cover near-Earth objects. Let's start with comets.
Comets are relatively small pieces, just chunks of ice and dirt in various degrees, so that when they get close enough to the sun, sunlight shines on the ice, vaporizes it, and creates like a little atmosphere around it. Now, sometimes if it's moving, it could create a tail. And that's when, you get Halley's Comet or things of that nature, where it's, it doesn't have to have a tail, but it can. And so anything like that is a comet.
Now, some artist interpretations of comets have sometimes shown that as fire shooting off, but by and large, it's always some sort of either gas or liquid that's coming off of a comet, correctly?
Yes, it's just outgassing of the liquids in the comet itself. They're just outgassing and it's just a little shiny from the sun, so it causes it to be a little bit of a glare and a little bit of a fuzz and a light.
Now, as far as the difference between a comet and an asteroid, an asteroid is basically the same thing, only it doesn't contain the types of gases and stuff that would form trails, right? It's like pretty much an asteroid.
Yeah, it's just dirt, rock, iron, things of that nature. It's all hard. Doesn't contain any ice or water or things of that nature that can expand and vaporize.
It's a pretty boring space rock, to be honest.
As long as they stay in place, just kind of rocks in space.
Now, when they are not boring is when they enter an atmosphere. Primarily what we start changing the terminology for them when they enter Earth's atmosphere. And these are when they start becoming meteoroids, meteors, and meteorites. First of all, I'm not familiar with the term meteoroid until we started doing our research for this particular show, but I did know that there was a difference between a meteor and a meteorite. So let's cover those differences real quick.
Well, meteoroids are really just small asteroids or comets, anything smaller than about roughly 30 feet or 10 meters or so. It can be a comet or an asteroid, just little chunks of those. Those are called meteoroids. Now, when you start getting into atmospheres, then the little shooting stars you can sometimes see, it's burning up in an atmosphere, the light phenomenon that you see, that is a meteor.
Oh, so the term meteor doesn't actually apply to the rock itself at all. It's the actual streak in the sky, the thing that we see when they burn up.
Yeah, it sort of encompasses it because the little rock or whatever it is streaking, so it's causing the light phenomenon. But it's only when it's streaking and it's a little shooting star that it is really a meteor.
And so when do they become called meteorites? What is the definition there?
If they survive passage through the atmosphere and they can make it down to the surface of a planet, then it is a meteorite.
Oh, okay. So those are the actual hunks that land on the surface of the planet.
Yeah, when it becomes terrestrial on Earth, then it's a meteorite with a T.
Okay. Now, there are other things that circle through our heavens all the time. You can see, for example, like shooting stars that are not meteors, that might just be space trash or whatever, just streaking through the sky. The term shooting star, obviously, is completely incorrect because stars don't shoot.
Yeah, not in this sense.
Right. But also you can see satellites sometimes.
Yes, you can.
Satellites are pretty easy to tell the difference, to be honest. For one thing, they're quite a bit dimmer than your average meteor as it shoots through the sky.
For the most part, they can get much brighter, though.
They can in certain circumstances, but they also universally travel slower. You're not going to get meteors going the speed of what a satellite orbits our planet.
No, generally not.
Right. So if you do see something flying through the sky, pretty slow moving, that's likely a satellite or UFO.
Generally, generally satellites are of a consistent brightness. They kind of travel along. They can get brighter, and that brightness is the sunlight bouncing off the solar panels. But generally those you see right after sunset or right before sunrise, because that's the time when the sun is
bouncing off of them.
With the perfect angle to bounce off them.
Right. Okay, so but let's get back to the near-Earth objects here, because I want to cover some of the facts about this. Like, I mean, is this really something that we need to be studying? So I mean, let's face it. You always hear the term space is mostly empty, right? So how much of our solar system is actually comprised of asteroids, of objects that could be considered near-Earth objects?
Well, not necessarily near-Earth objects. Most people have heard of the asteroid belt, that chunk of rocks in between Mars and Jupiter.
Right.
And the entirety of those makes up about 4% of the mass of the moon.
Like, just how many near-Earth objects are there out there that have already been categorized or discovered by current means?
Well, as of the filming of this episode, August 8th, over 8,000 objects have been discovered, with a little over 800 being larger than half a mile or so.
Now, are those the ones that we have come to consider potentially hazardous? They have a special category for themselves?
They do. They have a special category, and those categorize a little over 1,200 objects.
Oh, okay. Now, what exactly makes up the specific details of what classifies an object as potentially hazardous to life here on the planet? What is required to become that?
It's an object. That means an asteroid, a comet, a meteoroid, anything such that it has the potential to make a close, astronomically speaking, approach to the Earth within half an AU, or half the distance between the Earth and the Sun.
Okay, so that's a little bit closer than what they generally categorize as near Earth. Which,
about 19 times the distance between the Earth and the Moon. Anything that gets that close is potentially hazardous.
Now, one of the reasons that you guys might have all heard so many stories about, we almost got hit by an asteroid, was unfortunately, our detection methods aren't all that great right now. We'll get a little bit into that later on when we talk about some of the other resources that are out there on the internet to look at near-Earth objects. But unfortunately, our detection methods just aren't that great. So it has gotten to the point right now where many of these objects that get, within, 1.3 AUs of Earth
to be
are
near
not
Earth.
Yeah, are not discovered until as little as like 2 or 3 days prior to actually entering.
Just during the research part of this show, over the course of a week or so that I was researching it, I was checking back, and those numbers that I gave for how many are updated every day, and those numbers would jump up a couple every day or so. That it's new objects that have been discovered and tracked, and have been added to the list to watch.
But it should be clarified that we have not actually had an impact here on this planet of a potentially hazardous level within any of recorded human history.
That is correct.
That we know of, anyway. I mean, basically, back in ancient days, they could have written about it differently, and we just haven't translated it correctly or whatever. But we don't know of any hazardous...
There are no evidence of any.
And based on geological evidence, how frequently is this planet actually hit with a potentially hazardous impact?
Smaller objects of about 15 to 30 feet in diameter hit approximately the Earth once a year. When you get into the larger objects with a diameter of a kilometer or so, then they hit twice every million years or so. Even larger objects that are 5 kilometers, then that happens once every 10 million years or so.
Wow, so not very frequently at all. So
no, these larger objects are very, very seldom. They're
Right.
Very long scale time frames.
So don't believe all of the hype that you hear about these stories. Make sure that you're reading the articles if you ever get scared about one of these things. Unfortunately, the media likes to scare us. So if you see...
And if you're frightened, don't necessarily read a media article. Try to find a science...
Right.
focused magazine or,
in fact, check our
page
show notes. I think some of the resources that we have for this particular episode are really good at shedding light on those subjects in particular. Now, as far as impacts that we have had here on planet Earth, we have evidence of these, right?
Oh, yes. Yes, we do.
Impact craters and things like that.
Yeah.
But I didn't actually realize until we were doing our research for this show that people haven't actually known that these were impact craters for very long.
No.
Why don't we go over very briefly sort of the history of the discovery that these are impact craters? Where did it all begin?
It was only around the turn of the century that it was kind of decided or sort of discovered that craters were due to impacts and not collapsed volcanoes. It wasn't even until 1892 that a man called Grove Carl Gilbert first proposed that the craters on the moon were not due to volcanism, that they were actually due to impacts.
So even as recently as, what did you say, 1892?
Yes.
Folks still also thought that there was volcanism on the moon.
Yes.
Kind of a quaint idea looking back, but, well, watch some sci-fi from the 30s. You'll get even more quaint ideas.
Yeah.
So, but that was just the beginning of it all. It went on from there, and more discoveries were made.
Yes, a man named Daniel Barringer was a mining engineer. In 1903, saw there's a big crater in Arizona, sometimes called Meteor Crater, sometimes the Barringer Crater. And it was him who first said, I think this may be an impact. So he mined for the meteorite itself, but he was never able to find it. So he wasn't able to strike that final nail in the head for everyone, for them to decide. It wasn't even until the 1960s that we had definitive proof that there were actual impact craters on Earth.
It was that recent.
It was that recent.
Like less than 50 years ago. We've up until then, it was still generally thought that these were due to some sort of volcanism, some volcanoes or something.
Well, it wasn't until we really had satellites looking at the Earth that they started looking, and then they said, okay, so maybe we have impact craters. And they're like, whoa, wait a minute. There's a circle. There's a circle-shaped thing. There's a circle-shaped thing. And they started seeing these lakes or other things that you really can't notice except from satellite imagery, that how many craters we actually had on the Earth.
Right. We actually have a link in our show notes that's really fascinating. It's kind of a tour of most of the well-known that have been confirmed as impact sites here on Earth. And some of them, like you've just said, they're really, that you wouldn't be able to tell from the planet because like erosion has just completely wiped away one whole side of it, things like that. But so check that out if you're interested. Pretty recent phenomenon, though. I mean, recent for scientific means anyway, that we're only recently beginning to discover these things. Now, you said that Barringer didn't find the actual meteor, but there was scientific evidence eventually brought forward that proves this true, right?
Yes, in the 1960s, it was Eugene Shoemaker, who people might recognize that name from Shoemaker-Levy 9, the co-discoverer of the comet who hit that Jupiter back in 1994. But he made a key discovery that there was a certain mineral called stishovite. It is a rare form of silica only found in these certain rocks that have had extreme instantaneous overpressure.
Oh, which could only happen from like
something
landing from
smashing
space.
into the Earth. Yes.
Yeah.
So I said, aha, there's these certain minerals and crystal formations that only happen in these kind of things. So when they see these circle-shaped objects, they can go, if they can't find the meteorite itself, if it's disintegrated, or other phenomena that they just can't find it, it's under a lake or something, you can go and look for these minerals.
Or somebody wandered by and picked it up and walked off with it.
You can dig it out. Dig it up. But there's a certain mineralogy that you can look for and say, aha, yes, this is actually definitely a crater.
Okay. Now, since we know that things hit the planet, and we know that they can leave big impact craters, we also have all seen the movies, which I won't go into right now, about what can happen to life on this planet if a major impact event does occur. Now, let's just say, for the sake of argument, for the sake of sensationalism, that a near-Earth object is plummeting directly towards our planet, or close enough that we think that it might hit. And scientists feel the need that they need to go out and warn people about it, that they need to somehow quantify the risk associated with this particular object. What do they do? Like, is there a grading? There's gradient
scales. There are two different major ones. One, the Palomero Technical Impact Hazard Scale. It's more of a for the scientific side because it's a logarithmic scale.
I would just like to point out that that's a terrible acronym. Science has failed this one.
Yeah, they didn't really do the great acronym for this one. But it's more for the scientists anyway because 0, low scale, but a rating of 2 means it's 100 times more likely than a scale of 0.
So it's, what's the term, logarithmic? Right?
Yes, it's logarithmic.
So it gets exponentially more and more serious.
Exponentially more and more serious. So they created a different scale called the Torino scale, which is a method for categorizing them. It's sort of based on speed and distance and size and what they're composed of to say, what kind of danger would this pose? If it is going to just shoot through the atmosphere and burn up, it's not something to worry about. So it's low in the scale.
So you were saying they take the speed, the size, the chemical composition, all of this stuff, and they basically quantify it all down to a single numeric value that they assign to each near-Earth object?
Yeah, it's based on how likely is it to hit Earth. Okay, so it's going to hit Earth. What is it made of? What's the danger? There are iron meteorites, and there are also, they're mainly the ones that, actually impact and we can dig up, and it's a little chunk of iron.
Right.
So those pose a lot more danger, hitting someone's car or house that you may have heard of in the news, than something that's, loosely held together with rock that you're going to see, at your campsite and go, ooh, pretty, and then it's gone.
Right. Now, how about an example here? I mean, we've probably everybody watching, because you guys are at least somewhat interested in science, or you probably wouldn't be watching this unless you think I'm cute. Thank you.
Oh,
The term Apophis, probably everybody has heard this because it is one of the most famous near-Earth objects discovered over the last decade or so. Yeah. But what you might also not know, or that might be one of the reasons it's so famous, is that Apophis actually holds the record of being one of the highest, what would you call, deadliest potential on the Torino scale, right?
It just had the highest danger rating,
right?
Sort of, on the scale. It was 4, I believe.
Of any
at one time.
Of any object that we've categorized.
Yeah, it didn't maintain that level, but it had it at one point.
Let's talk a little bit about Apophis, because this was a big news story. I mean, because when it first was discovered back in, 2004 or something like that? I mean, a lot of scientists, December of 2004, a lot of scientists actually thought this one's going right for us. I mean, there was some serious...
Well, they kind of said it has a 2.7% chance of hitting the Earth.
Well, yeah, but again, astronomically speaking, a 2.7 chance of hitting the Earth, that's like, that's threading the eye of a needle. That's a huge percentage chance of a near-Earth asteroid object, not asteroid, actually hitting us.
Yes.
Which is one of the reasons it ended up rating so high. But when they did discover, okay, it's going to miss us and it's going to miss the moon, which didn't happen until like 2007. Am I getting my dates right here?
Well, almost. In August of 2006, it passed through what they called a gravitational keyhole, which was a special place, in the Earth-Moon system that meant it would alter the asteroid's orbit such that it would come back around for a second go at us.
Whoa! So it's bad enough that it was going to have one shot at us, but if it passes, so they calculated that it would have a good chance of passing through this. They called it a gravitational keyhole. Awesome term. That sounds so sci-fi. So Star Trek. If it passed through that, it would loop back around for a second shot.
Yes.
As if we weren't getting enough out of Apophis. But
we had round 2 to come. But
right. It ended up being calculated that it has an infinitesimally small chance of actually hitting that keyhole, right?
Yes. And that the keyhole would just mean it had another chance in, 2036. But the stars didn't align for that little asteroid. And we are much safer than we once feared we were.
But it's still going to probably be one heck of a light show when it passes through our system in 2029.
You might be able to see, if you have a telescope, and know exactly where to look at the right time. Or have radar or something. But if you look up, you're not going to really see much in the sky just by eye.
Right, just by looking up and happening to see it. But, despite Apophis being downgraded from being such a massive threat, there are still studies going on about this, as well as some of its cousins, you might call them.
Yes.
Other near-Earth objects of about the same size and mass, and probably also categorized as somewhat dangerous. There is a spacecraft known as Dawn, which you introduced me to here, that's studying a couple of these known as Vesta and Ceres.
Yes.
Now, what exactly is Dawn equipped with, and what is it doing out there? What is it going to study in order to help us learn more about these?
It's going to take pictures, photography, visible and infrared, gamma rays, neutron spectrometers, gravity science. We can get some clue of what they're made of, by the spectrometry and see what is there, but also how our little spacecraft orbits it, how it's affected by the gravity of the object itself.
So am I understanding correctly? We actually shot a spaceship out there to orbit an asteroid?
Yes.
Is that really?
Yes.
We
and it's
can do
orbiting
that?
right now.
Wow, go us. Go science.
Go science, indeed.
But that's only one of
Yes.
literally dozens and dozens, maybe even hundreds of studies that are going out there.
Of
The studies that are going on for near-Earth objects. Because as I said earlier, our detection methods are not all that hot at the moment, which means that the more eyes we have pointing at the heavens, the more chance we have of actually discovering something before it gives us a really bad day.
There are some near-Earth asteroids and asteroids in general they're discovered from amateur astronomers who go out there and they watch their little patch of sky night after night, and if they see something pass through, they shoot it down the line and something else is discovered.
Now, as mentioned earlier, we sometimes have as little as a week of advance notice. So it is right now a sad truth that if an impact event were to occur that could potentially impact life on this planet, we might not have a whole lot of warning, which is exactly why all of these studies exist, to increase the amount of potential warning that we could have to prevent a major catastrophic event, or to at least prevent the extinction of the human species in the event of a major impact.
Useful.
Right. Now, we've got links by the dozen in our show notes. There are studies, there are social media sites, there's additional links, and Mars has even collected a whole bunch of news stories about past near-Earth objects. Really just an incredible field to be studying right now, because there's so much more to learn about, not just are we going to live through this?
Well,
But, I mean, some of these objects that impact our planet are from alien origin. I mean, not like alien, not like alien, not alien. That's not what I meant, but extraterrestrial. They are rocks that have originated from elsewhere in the solar system. And, if we were to, discover microbes living in some of these, or, anything like that.
There are some recent stories that say they're seeing some biological origin stuff in asteroids. There's always the question, is it, contamination? But it's becoming more and more possible that the, very basic bits of life could be on these asteroids.
Right. Well, there's even an old, I don't even know if it's a commonly held theory anymore, that life on Earth originated from some sort of extraterrestrial rock that landed, like an ice comet that contained bacteria. Panspermia, I think that's the name of the theory the chat room just mentioned. So
it came from another planet transferred to here.
Yep. So there's all sorts of crazy, wacky science stuff going on with near-Earth objects, and I would recommend any of you interested in this stuff, check out our show notes.
Oh, yeah. There's a great link in there to a website that you can go through and interact and say, what if I smash a school-shaped object of iron into the Earth at this angle? What happens? And
I love those kind of studies.
The Earth is completely obliterated.
Also,
it becomes an asteroid belt.
If you guys are on... if you guys are gamers at all, if you like watching things blow up, there's actually a game on Steam, that you can get called the Universe Sandbox, where you can smash objects into each other, including smashing the moon into the planet Earth. It's all good fun. But if something like that major were to come along, we can always just call Bruce Willis, right? He'll save us with his team of extreme miners. They'll get up there and blast it to bits. Do you want to take a little time and tell us? Okay, just since we're talking about near-Earth asteroids, some of you that might know that you've been a fan of Jupiter Broadcasting, we've mentioned it numerous times that Mars hates the movie Armageddon because of how scientifically inaccurate it is. So do you have any major gripes that we could go over just real quickly here?
Oh, goodness. I had so many gripes coming out of the theater. We weren't even out of the parking lot, and my family unanimously voted I was not allowed to talk about the movie anymore. They're like, all right, you're ruining the movie. It was just for fun.
Well, is that even a possibility to
the shape of it, it was more like a comet, how it kept shooting off those crazy gases.
Right. Now, let's just cover one major thing. If let's say a large object was on a collision course with Earth, is it even feasible to send a spaceship out there and blow it up and prevent it from destroying life on Earth? Is that even a possibility?
It's certainly possible. Generally, if you're going to blow it up, that means you just have a whole bunch of smaller chunks of stuff flying towards the Earth.
Because of momentum. It's just going to keep flying on the same line.
It's not like you blow it into complete smithereens.
Yeah.
It's not a destructo ray.
Right.
Generally, when scientists are talking about it, they're talking about nudging the orbit. So you want to know about it far enough and out. Maybe you land a rocket on there and you start, blasting a rocket off on the surface.
Yeah, you attach a big jet engine to it and start pushing it.
Yeah, big jet engine. There's even been talks of just like shooting a laser at something, because that in itself would alter it just slightly.
Mm-hmm.
So if you have a long enough warning system, which is why you want to know exactly where these are.
Mm-hmm.
If it's going to be 100 years before it hits, then
you got time. You can start shooting it with the laser right now.
Move the orbit and watch what it does. Make sure that doesn't, doom you in a different point in time. But, there's a lot more better ways of doing it than blowing
launching Bruce Willis at it.
Yeah. let's
But it made a great movie, right? Everybody loves that. No, okay. Well, okay. I don't want to go down that road too much. I'll just let's wrap up this episode right there. So I want to tell you guys, next week we will be covering the Q&A that we introduced on last week's episode, which was all about old wives' tales and scientific misconceptions. Basically kind of a true or false thing. We're going to get a little Snopesy on you guys and talk to you a little bit about the urban legends of science and old wives' tales and stuff like that. And we've already got some good suggestions. Unfortunately, if you're watching this on the day that it's published, it's too late to send us your questions because we need time to research them. But stay tuned. And if you do have any questions along this line or anything about science, you can always send us an email because they might make it into future shows or future QAs. Now, some of the best ways to do that are really to, right wherever you're watching this, leave us a comment right below. YouTube is fine, but if you're on YouTube, you can click in the description below and go to our show page, which is our primary source of show feedback. But if you don't want to do that, you can always email us
at SciByte@JupiterBroadcasting.com.
That is correct. You're getting so good at that. And of course, we've also got Twitter accounts. I am JB Jeremy.
And I am JB_Marsbase.
And that is pretty much it. I mean, you can also go over to Jupiter Colony and talk to all the other science nerds about anything that you like to. In fact, there's a thread in there. I'll bring that up on a future Q&A because there's a couple good topics already going in our forums, and I would recommend you guys go check that out. That's again at jupitercolony.com. So I guess that's it. I guess we dodged a bullet on this one, right? No? Was this an earth-shattering episode?
Excellent.
Okay, well, we'll see you guys all next week. Until then, keep your science on, right?
Yes.
All of the YouTube comments that we get, every single one of them is going to be about Armageddon.
Oh, no. No. Maybe it'll make people scared and be like, I should check the show notes.
I know. Oh, God, tell me how to survive. You won't. Don't bother.